And last time we were talking about the coordinate system and says that there's only one single way. There's only one way to express there's only one coordinate system that can be expressed using the basis vector as the combination. And what does that coordinate system mean? Suppose we are given a set of vector. This set a capital B, 一个大写的 B, being the collection of basis vector, and B1 to BP is a basis. So the next time we introduce what is a standard basis. Standard basis is like this, 1, 0, 0, and 0. Oh no. 0, 1, 0, and 0, 0, 1. Suppose this is B1, B2, and B3. And we let the capital B be the collection of these three vectors. And this is a basis for a subspace H. The sentence has an example like this. And for each x in the subspace H, the coordinates of x relative to the basis are the weights C1 to CP such that some x, suppose I have some x being 4, 5, 6. I randomly pick such a x, then I can express it as 4 times 1, 0, 0 plus 5 times 0, 1, 0 plus 6 times 0, 0, 1. And the collection of x with x relative to basis B, this one is called coordinates of x relative to the basis B, is a vector being 4, 5, 6. And this is because that I'm choosing the standard basis as my basis right now. So you can see that the value of x is exactly the same with the coordinate of x relative to basis B. This is a coincidence， 就是说这是一个巧合，因为我在前面选择这个 basis 的时候，我是选择 standard basis， 所以 value of x vector 会跟这个中括号 x， 然后有一个下标 b， 被叫做 coordinates of x relative to the basis b。当我刚好选择这个 basis b 作为 standard matrix 的时候，那这个任意的 vector x， 它跟它的 coordinate 中括号 x 有一个下标 b， 它的 coordinates of x relative to the basis b 会刚好是一样的。那但是如果我选的不是 standard basis 的话，那这个时候我任意选择一个x value 456，那么它可能会用不同的 linear combination 的 parameters， 就不见得会跟它这个原本的 x456会一样了。Okay, so this is just the definition, and we're again introducing some terminology. We say this, we use these notations to say the coordinate vector of x, or the b coordinate vector of x. So here's just, because this is just a terminology, so you can just try to get familiar with it. there is nothing hard, but then you need to get familiar with the way how people say it， 就是说这个其实并不困难，它的里面的数学并不深，但是它就是要试图把一些彼此之间的关系用一些词汇表达出来，那同学就需要熟悉它就好。So we are having an example. Suppose we are having a basis. We have seen this notation before. This is the basis using the capital B, and then containing two vectors v1 and v2. 那这是我们前面见过的这个 notation， 我们用大写的 B 来代表一个 basis。那这个 basis 里面呢，它有两个 vector， 一个是 v1， 一个是 v2。那这时候因为不是 standard basis 的关系，所以 v1 是362，然后 v2 是-101。Determine if X is in the subspace, and if it is in the subspace, find the coordinate vector X relative to B. And this is again just the terminology that we have just seen. So we can try to use the linear combination to combine, use C1 and C2 as the parameters to combine V1 and V2, and see if it equals to X, 3, 12, and 7. The scalars C1 and C2, if they exist, are the B coordinate of X automatically. So the next step is to solve for the linear combination, the system, and find out that C1 equals to 2 and C2 equals to 3. And then we use this notation, 中括号包含 X, 然后有一个下标 B. We use this notation, which is a bracket containing X in it and with a subscript B to denote the B coordinate of X. And then it equals to this vector 2, 3. And the basis B determines the coordinate system of the subspace H, which can be visualized in this way. And next we define what is the dimension. The dimension of a non-zero subspace H is denoted by DIM. H is the number of vectors in any basis for H. Like we count the number of vectors in the collection of that capital B with a braces, 用大括号包含起来的这个basis vector. And then we count the numbers. Suppose we counted 1, 2, 3, and there are 3 vectors in the basis. So the dimension of such a subspace will be 3. And that's also true if you count the number of components in one of the basis vector, like 1, 0, 0, 0, 1, 0, 0, 0, 1. And we count the number of components in each basis vector, and it's also 3. The dimension of a zero subspace is defined to be 0. It says that if the subspace containing only origin, then the definition of such a subspace is said to be 0. If we are having a space of Rn space, then Rn space has dimension n. Every basis for the Rn space will consist n vector. This is by definition. And the plane through origin in the R3 space is a 2-dimensional, and a line through 0 is a 1-dimensional. So if it's a plane, then the dimension of a plane is 2. If it's a line passing through 0, then the dimension of the line is 1. And the next definition is also very important. It's called the rank. The rank of a matrix A, denoted by rank A, is the dimension of the column space of A. So column space of A, next time we are saying that we are collecting the value of B such that AX equals to B for a given matrix A. So the dimension of a column space is called the rank. And all right, so we're done for today. And then next time we should proceed to this example. Do we have any question?